Good day, students. This will be our lecture record para sa ating statics of rigid bodies. For easy access para sa review ninyo for our midterm topics. So for this video, we have the topic, ang ating statics of rigid bodies. So first, what is statics? So statics is the physics that treats object at rest at rest or objects in constant motion. So ang daming S. Statics is a branch of mechanics which studies the effects and distributions of forces of rigid bodies which are and remain at rest. In this area of mechanics, we have the body in which forces are acting is assumed to be rigid. So next, i-define natin what is equilibrium. So equilibrium, if yung ating system of forces acting on a body keeps the body in a state of rest, and then the system of forces is said to be in equilibrium. Alternatively, if the resultant of the force system is zero, then the force system is said to be in equilibrium. When all the forces that act upon an object are balanced, then the object is said to be in the state of equilibrium. The forces are considered to be balanced if yung ating rightward forces is equal or balanced sa ating leftward forces. And then same goes sa ating upward forces. They are balanced by the downward forces. So meron tayong conditions regarding for the equilibrium of the rigid bodies. So first condition for this is for rigid bodies which is not moving at all, we have the following conditions. So first, yung ating vector sum or the sum of the all external forces on the rigid body or rigid object must equal to 0. So we have here yung ating formula or yung ating isa-satisfied equation. So yung summation of all the forces is equals to 0. So when this condition is satisfied, we say that the object is in transitional equilibrium or wala siyang movement horizontally or wala siyang displacement. It really only tells us that the acceleration due to the center of mass or yung ating A sub cm is 0. But of course, that includes the case where the object is motionless. Next condition is yung ating torque. So the sum of all the external torques on the rigid object must equal to 0. So we have here a satisfying equation. So summation of torques is equals to 0. So when this condition is satisfied, we say that the object is in rotational equilibrium. It really only tells us that yung ating alpha or yung ating rotational or angular movement about the given axis is 0. But again, that includes the case where the object is motionless. So when both yung ating formula na summation of forces equals to 0 and yung ating summation of torques is equals to 0 are satisfied, we say that the object is in static equilibrium. Nearly all the problems we solve in this discussion are two-dimensional problems. Kumbaga, nasa X and Y plane or XY plane. And for this equation sa ating summation of forces equals to 0 and yung ating summation of torques equals to 0, marireduce siya sa summation of horizontal forces or yung ating nasa x-axis is equals to 0 And then, yung ating summation of vertical forces or nasa y-axis equals to 0. And then lastly, yung ating summation of torques or ating angular rotational moment or forces, moment of forces is equals to 0. Okay. So next, we have the equilibrium of concurrent and coplanar force system. So i-define lang natin ano ito sila. So yung ating equilibrium is under yan siya sa ating Newton's first law. If and only if an object's mass center has 0 acceleration, then the sum of all forces acting on the body or yung ating object is 0. Kumbaga, the entire body is at rest, wala siyang motion. So the mass center has 0 acceleration. Next, define natin what is coplanar force system. Coplanar force system is when the lines of action of all forces lie in a common plane. So kumbaga, naglay lang siya sa X or Y plane. Next is yung concurrent force system natin is when the lines of action of all forces intersect at a common point. Kumbaga, meron tayong point O, nag-intersect lahat ng ating forces on that particular point. So, sample natin for our concurrent force system. So, example, meron tayong force F sub 1. This is our F sub 1. And then meron tayong F sub 2. Okay. F sub 2. So, for this two force, meron tayong point O, which is yung point where the two forces intersect. So, for this this is our sample para sa concurrent force system. Next, yung ating triangle law. For this law, only 3 forces ang ating i-consider to form the triangle. So if 3 forces are in equilibrium, then they form a closed triangle when represented sa tip-to-tail arrangement. For this example, meron tayo dito sa ating figure. So we have 3 forces, F sub 1, F sub 2, and F sub 3. So gawin natin yung kanyang tip-to-tail arrangement. So, meron tayong figure 1-A or figure 1A. So, yan yung representation ng ating triangle law. Okay, next class is yung ating Lami's theorem. So, Lami's theorem states that if a system of 3 forces is in equilibrium, then each force of the system is proportional to the sine of the angle between the other 2 forces. And constant of proportionality is the same for all the forces. Thus, with the reference noong dito sa ating figure 2, we have F over sine alpha, F sub 1 over sine alpha is equal siya sa ating F sub 2 or force 2 over sine beta. And then yung ating force sub 3 is equal to the sine gamma. So yung ating equation na ito is yung ating magnitude and then yung kanyang opposite na angle. So, ganyan yung kanyang pag-formulate. So, F sub 3, example lang ha, F sub 3. So, over sine, ang kanyang opposite angle is gamma. Okay, so F sub 3 over sine gamma. Note lang, while using Lami's theorem, all the 3 forces should be either directed away or all directed towards the point of concurrence. So yung ating force system for the Lami's theorem or yung ating triangle law is naka-concurrent force system. Next is yung ating rotational and translational equilibrium. Daanan na natin to kanina. Recap lang tayo. So angular speed is not changing with time. There is no resultant torque, and therefore zero yung kanyang rotational velocity. So that is our rotational equilibrium, or yung ating rotational equilibrium exists. The next is yung linear speed is not changing with time. There is no resultant force, and therefore zero acceleration. Thus, transitional equilibrium exists. So, sandali lang, hindi nag-sky. So, before we proceed sa ating mga sample problems, balikan muna natin. Balik muna tayo dito. So, we have two important facts for working static problems. So, first, the force of gravity acts on all massive objects. In our statics problems, it acts on all the individual mass points of the object. One can show that for the purpose of computing the forces and torques of rigid objects in static problems, we can treat the mass of the entire object as being concentrated at its center of mass. So, nasa gitna tayo mag-a-act para sa ating weight ng ating object. That is, for an object of mass m, we can treat gravity as exerting force mg or mg downward at the center of the mass. This result depends on the fact that the acceleration of gravity, yung ating g, is usually constant over the volume of the object. Otherwise, it is not true. Next, while there is only one way to write the conditions for the forces of a rigid object summing to zero, we have a choice in the way we write the equation. For the total torque, para dun sa ating equation 3.3, balikan lang natin. So, yung ating summation of horizontal forces equals to 0, summation of vertical forces equals to 0, and then summation ng torques natin is equals to 0. For the equation 3.3, it does not specify the choice of the axis for calculating the torque. In general, it matters a great deal which axis we pick, but when the sum of torques about any of the axis is 0 and the sum of forces is 0, kumbaga nasa transitional equilibrium, then the sum of torques about any axis will give 0. So for statics problems, we are free to pick the most convenient axis for computing the summation of torques. Often, this will be the point on the object where several unknown forces are acting, so that the resulting set of equation will be simpler to solve. Okay, so yan yung ating two important facts for working static problems. So next is yung ating strategy for solving yung mga samples natin sa rigid object in static equilibrium. So strategy for solving problems in static equilibrium. First, determine muna natin lahat ng forces that are acting on the body or doon sa ating object. They will come from the other object with which the body is in contact. Example nito yung support, walls, weight resting on them, and as well as the gravity. The next, draw kayo ng free body diagram. Draw a diagram and put all the information you have about these forces, the points on the body at which they act, their magnitude if known, and then yung kanyang direction if known. Next, write down the equation for static equilibrium. For the torque equation, you will have a choice of where to put the axis. In making your choice, think of which point would make the resulting equation the simplest, and then solve the equation. If the problem is well posed, you will not have too many or few equations to find all the unknowns. So, yan yung ating strategy for solving problems in static equilibrium. So ngayon, magsosolve na tayo ng ating mga sample problems. So first, we have here our equilibrium of a particle or equilibrium ng ating mga forces. So we have this figure. Wait lang. So meron tayong 4 na forces acting on the on a point. So find the magnitude and direction ng ating force F. So first, kukunin natin yung mag-equate tayo for the components. So yung I natin, representation yan siya nung ating x-axis or yung sa ating forces acting on the x-axis. And then yung J is yung forces acting on the y-axis. So, magsa-summation muna tayo. Another way ito, maraming way. Madaming kumbaga technique for solving static. So first we will have this, so we break down natin siya for different components. So meron tayong, wait lang. Okay, so first is magsa-summation muna tayo. Summation of all forces equals to 0. So, equals to 0. So meron tayong force F, and then i-draw muna natin dito. Kumbaga ito yung ating figure or free body diagram. Meron tayong force F, right? Oh. Okay, so wait lang. Bagawin muna natin ating figure. So, yan. Ilagay ko na yung ating figure. So, summation. Summation muna tayo of all forces equals to 0. So, sanay lang. Sulat na natin. So, summation of forces is equals to 0. So, we break down natin siya into x and y components. So, we have F. So, first muna tayo sa F or yung force F natin. And then, we break down natin siya sa x and y component na represented as I and j. Okay? So, open parenthesis. So, yung kanyang x component is this part. And then, cos or sine. Cos. Since yung ating angle is nasa x-axis. So, cos ang ating x component. So, cos. Then, yung ating angle is unknown. So, represented as theta. And then, yung kanyang representation as I. So, since nasa quadrant 1 sila, yung x natin is positive and then yung y natin is positive. Okay? So, positive cos theta I and then yung y is positive din. So, positive sine theta J as yung representation ng x and y natin. So ito yung ating x component, ito yung ating y component. So next, yung ating 4.5. So plus. So yung ating 4.5 is meron lamang siyang x component, which is directed sa ating second quadrant, which is yung ating x is negative and then yung ating y is positive. Diba? So yung ating force is 4. Okay, wait lang. Negative 4.5 and then cos 0, di ba? Kasi nandito man siya sa ating x-axis na kalay, so gagamitin natin ng cos. So cos and then angle is 0, so cos 0. Okay? So yung 0 natin, taken as 1 yan siya. So tignan nyo sa calculator nyo, 1 yan siya. So 4.5, negative 4.5 is times 1, so negative 4.5 yan siya. Okay? So next, kunin natin yung ating 7.5 force with its component. So representation lang, positive lang. And then 7.5. And then yung ating component or yung ating force is directed siya sa ating third quadrant, which is negative, negative. So yung ating x-axis is this part, di ba? Di ba? Pero since yung ating angle is nakalay sa ating y-axis, yung ating x component is sine. So sine 30. So negative sine 30. Okay? And then representation, yung ating I. Next is yung ating y component. So, nasa third quadrant. So again, negative. So negative. And then yung ating y-axis, y component is cos. Cos dahil yung ating angle is nasa y-axis nakalay or naka-direct. So negative cos 30 J. Then last, yung ating 2.25 na force. So plus 2.25 open parenthesis. Fourth quadrant, which is yung x natin is positive, yung ating y is negative. So, yung ating x component is this part. So, yung ating angle is 60. Nakalay siya sa ating x-axis. So, ang ating x component para sa ating force 2.25 is cos 60. So, positive dahil directed siya towards the positive direction. So, positive cos 60. So, cos 60 na lang. And then, representation para sa ating x-axis ay. And then, sa ating y component is negative, dahil directed to negative direction, and then negative sine 60. So, negative sine 60. Okay, close parenthesis equals to 0. So, next is i-equate natin siya o ipapartner natin lahat ng I. Ito I pala ito, nawala, kulang. Lahat ng I and then lahat ng J. So, yung equate natin siya ay lahat ng I. So, meron tayong F cos theta I. So, pero alisin natin yung I na ha. So, F cos theta. Okay, next. Negative 4. Natin na, I lang. Negative 4.5. Ito yung ating I. So, negative 7.5. Sine 30. Then last, plus 2.25 cos 60. Then equals to 0. So equation 1 natin yan. Equation 1. Next, doon sa J. Yung part na sa J natin. Yung equation, or equate natin siya with all the J variable. So meron tayong F sine theta. Okay, next, wala tayong for the force na 4.5, directed lang siya sa ating x component and then wala siyang y component. So, diretso na tayo sa 7.5. So, sa 7.5, ito yung ating j variable. So, 7.5 times negative cos 30, meron tayong negative 7.5 cos 30. Then, next is 2.25 times negative sine 60. So, meron tayong negative 2.25 sine 60. Okay, so equals to 0. So, ito yung ating equation number 2. Okay, so next page. So from our equation number 1, the equation number 1 natin, yan yun siya yung ating x component, di ba? Yung kanina, x component. Or yung ating f of x. Okay. So, equate lang natin siya, yung ating, equate natin siya sa f of f cos theta. So, meron tayong equation, di ba? Balikan nyo lang sa video. So, yung ating equation ng equation 1, f cos theta. So, equate natin siya doon sa mga values. So, ilipat lang natin. So, from negative, magiging positive na. So, yung negative 4.5, positive na. So, 4.5. And then plus 7.5. Kasi kanina, di ba, yung nandito siya, negative itong ating 7.5 sine 30. So, kung ilipat na natin siya sa kabila, other side ng ating equation, pag i-equate, is magiging positive. So, 7.5 sine 30. Then negative 2.25 cos 60. Okay. So, calculate nyo ito. Malalabas sa inyong calculator ang value na 7.125. Okay. So, ano ang unit natin? Kn, kilonewton. Next, equation number 2. Yan yun siya yung ating y component, which is f of y component. Okay. Dali lang. Yan yun siya, yung ating f of y, or yung forces at vertical forces. Okay. So, meron tayo sa equation 2. Kanina, equate natin siya sa equation ng f sine theta. So, f Sine theta is equals to F 7.5 cos 30 plus 2.25 sine 60. So again, i-calculate nyo ito, lalabas ang value na, compute nyo ito, lalabas ang value na 8.444 kilonewton. Yung unit natin again, kilonewton. Okay. So meron na tayong x and y component niya, kumbaga yung f of x niya and f of y. So next, kukunin natin ang kanyang magnitude, yung magnitude ng ating f or yung ating kabuang f force, force f. So meron tayong equation para dyan na f squared is equals to f of x squared plus f of y squared. Okay, or f is equals to square root of, anong value ng ating f of x? 7.125. So, diretso natin. 7.125 squared plus f of y natin, ang value niya, 8.444. So, lagay natin dito, 8.444 squared. So, may value tayo ng ating force F na 11.05 kilonewton. Okay. So, yan yung ating value for the force F. Next, kukunin natin yung kanyang theta. So, madali na lang itong theta niya. Yung theta natin is makukuha sa equation ng tan theta is equals to y component over x component. So, anong value ng ating f of x or f of x over f of y? So, we have, nako. Sorry. F of y dapat to over f of x. So, value dito is 8.444 over 7.125. Okay? So, i-calculate lang ninyo sa inyong calculator yung magiging, sa calculator ha, dapat arc tan. So, sine, pindutin nyo muna yung ating shift and then yung tan. So, lalabas yung value na tan negative 1. Okay? And then, magaganyan siya, di ba? So, equate nyo lang yung factor sign para ma-input nyo dito yung ating f of y or yung 8.444. And then, sa baba, yung ating 7.125. So, yan yung ating theta. So, ang theta natin is, palabas sa calculator nyo, is 49.84. Degrees. Okay? So, dyan nagtatapos ang ating problem number 1, yung ating equilibrium of forces. So, we have here yung ating summary of answers. So, yung f of x natin, which is f cos theta is equals to 7.125 kilonewton ang kanyang value. And for the y component, which is yung ating f sin theta, ang value is 8.444 kilonewton. And then, yung ating theta for this theta para sa ating force F is 49.8. Pero 2 decimal points tayo for the theta. So 49.84 yung ating lumabas na value. And for the magnitude F, so here we have 11 kilonewton. Pero yung kanina, 2 decimal points tayo, so 11.05 kilonewton. So here are our summary of forces. Okay, next problem natin is illustration para sa rope. So meron tayo ditong figure ng rope. Kumbaga, meron tayong rope A and then rope B. And then meron tayo, wait lang. Nakakabit siya sa ating, kabit siya sa ating, kumbaga concrete ito or truss. So, and then meron tayong weight na 80 Newton. So, again, determine natin yung mga forces na nasa ating diagram. And then yung kanyang mga angle and direction. So, for our free body diagram, meron tayong ito. So, meron tayong force A, force B, and then yung ating weight na 80 Newton. And then dun sa ating force B, meron tayong 60 degree angle. Okay. So kung anong angle dito, pwede natin siya malipat opposite side niya. So kung dito siya sa taas, sa baba, pwede natin siya ilipat dito. So yan yung ating free body diagram. So kukunin natin, find the tension in ropes A and B. So mag-illustrate tayo dito using yung ating triangle law. So since naka-equilibrium yung ating ballpen, yung ating system, so yung triangle law ang ating gagamitin. So sandali lang ha. So giano ko lang yung ating free body diagram, gi-copy ko lang. So para malipat natin dito na slide. So continue tayo. So for this force system, pwede natin gamitin again yung ating triangle law. So i-draw muna natin yung ating triangle figure. So meron tayong, kumbaga, force B. And then yung B, ito yung ating B. Yung ating A. Wait lang. Masyadong. Wow. So again. Hindi nakikisama. Sandali lang. Isama ka. So ito yung ating force B. Okay. A. And then yung 80 Newton natin. Force B. Yung A. And then yung 80 Newton. Okay. So dito, di ba kanina, meron tayong 60 degrees. Pangit niya. And then ito naka-ano siya, 90 degrees. Okay, so naka-right angle siya. So ito yung ating force B, force A, and then yung 80 Newton. So para sa ating triangle, dapat within the triangle, meron tayong 180 na total angle. So meron tayong 90 plus 60. So meron tayong 150. So meron tayo dapat ditong 30 newtons. 30 newtons, 30 degrees. So, yung sign niya, sign equation or yung kanina, yung proportionality equation para sa sign, kumbaga, yung A natin, yung force A natin, yung opposite niya is yung ito, angle na ito. So, sin 30 is equals to B. Opposite niya, sin 90. Equals to 80 and then opposite angle niya is 60. So 80 sin 60. Okay. So equate lang natin siya, A over sin 30 equals to 80 sin 60 para isa lang yung ating unknown. Para makuha natin yung ating A and B na magnitude. So first yung sa A. So A over sin 30 is equals to 80 sin 60. Okay. Ano ba yan? Wait lang. Ay, lumabas yung... Ayan na yan. Okay, okay, yung A natin, equate lang natin, lipat natin ito siya dito. So, magiging A equals to, malilipat ito dito sa taas niya. So, 80 sin 30. Over sin 60. Okay. So, i-input nyo ito sa calculator. May value tayong lalabas na 46.19 Newton. Okay, 46.19 Newton. So, regarding sa ating decimal points, from 4 decimal places tayo, ngayong midterm, lahat na equation nyo dapat nasa 2 decimal points para lalabas uniform, yung uniform tayo lahat, yung lalabas na value. So meron tayo para sa A, force A na magnitude na 46.19 Newton. Next, para sa ating force B. So mangyayari niyan, sin B over B over sin 90 equals to 80 over sin 60. So dito sa next na lang ha. So B over sin 90 is equals to 80 over sin 60. Then, lipat natin ito dito para B na lang matitira. So, B is equals to 80 sin 90 over sin 60. So, may value tayo ng magnitude B na i-input nyo to sa calculator nyo. Ang value na lalabas is 92.38 Newton. So, 92.38 Newton. So, ito na ang ating, dito nagtatapos yung ating illustration or sample problem para dito. So, ito yung ating free body diagram for this equation. And then ang kanyang value para sa B is 92.38 Newton, and then para sa A is 46.19 Newton. Okay. So another illustration naman para sa rope, meron tayong another figure. Okay, sandali lang. Okay, so next, meron, again, ito ating next problem. So rope A, B, and then meron tayong weight na 500 Newton. So this is the figure, and this is our free body diagram na figure. So next. So lilipat ko lang dito. So way natin sa pag-solve dito is yung summation of forces X and summation of forces Y. So okay, nako naman. Okay. So summation of forces X is equals to 0. Okay. So yung ating X is nasa A lang, force A and force B. So ito yung ating X niya, di ba? X component niya. Okay. So yung ating theta, naglalay siya or nasa x-axis, naka-direct yung ating mga angles. So meron tayong 35 degrees sa ating force A and 55 degrees sa force B. So for that, kukunin natin yung kanyang mga x components. So for A, meron directed siya sa negative direction. So negative A cos, since naka-direct yung ating angle sa x-axis, so cos ang ating gagamitin. So cos 35 is it plus B cos 55. Okay, 55 is equals to 0. Okay? So equate lang natin siya, na ililipat natin yung ating B dito sa kabilang side ng ating equals. So magiging A cos 35 is equals to B cos 55. So equate natin siya na magiging variable natin yung ating B lang. So maging yung value ng A sa variable ng B. So A is equals to B cos 55 over cos 35. So next, yung summation of forces Y. Okay, dito natin siya gawin. So summation of forces Y is equals to 0. So for this, ito both side natin. So ito yung kanyang Y component and then Y component niya. So since opposite na sa kabilang axis nakalay or naka-direct yung ating angles, so yung ating mga Y component is naka-sign. Sign na ating gagamitin. So directed siya positive. So positive ang ating A and Y axis. A and B axis. Yung dating weight is directed sa negative. So negative ang ating sign. So positive A sin 35 plus B sin 55 minus W equals 0. So, equate lang natin siya na ililipat natin yung ating weight sa kabila. So, magiging positive ito siya sa kabila. And then, equals na natin siya sa 500. So, A sine 35 plus B sine 55 equals to W, which is 500. So, ito yung ating equation for F sub Y. Ngayon, equate natin siya na makukuha natin yung value ng B. Diba? Gagamitin natin ito, itong value ng A na ito, substitute natin dito. So, itong data na ito, dito natin siya ilalagay. So, substitute na natin. So, open parenthesis, B cos 55 over cos 35, close parenthesis, and then ito naman na data na ito. So, sine 35 plus B sine 55 is equals to 500. So, ito siya, pwede na ito i-input sa calculator. Okay? Itong B na ito, gawin nyo siyang alpha x and then shift solve na ninyo. So, alpha x cos 55 over cos 35 sine 35 plus alpha x sine 55 equals 500. So, sa calculator nyo, shift solve equals, so may value na kayo ng ating B. So, ang B natin, may lalabas na value na 409.58 Newton. So, ang ating unit is Newton. So, para sa A, from the value na B, cos 55, over cos 35. So, itong variable na B na to, substitute ng itong value na ito, 409.58, meron tayong value for magnitude A na 286.79 Newton. So, dito, nagtatapos yung ating problem. So, meron na tayong magnitude ng ating A and B. So, ito yung mga values natin. So, next class, yung ating ideal cable. So, tapos na tayo sa ating ropes illustration. So, next, ideal cable na tayo. So, before we proceed sa pag-solve ng ating cables, let's assume the following condition for the ideal cable. So first, neglect natin yung weight ng ating cable. So massless siya, yung ating assumption. Next, neglect natin yung kanyang stiffness. And then, force parallel to cable. And then yung force na i-consider natin, i-assume natin tensile only. And then, neglect the stretching ng ating cable. So, inextensible yung ating cable. So, yan yung mga assumption for the condition ng ating ideal cable. So, here we have the illustration para sa ating cable. Find the forces in cable AB, ito A, B, and then yung AC. Kung may mass tayo na 12 kg, itong ating traffic light, kumbaga may mass siya na 12 kg. So yung procedures para sa ating ideal cable, first, we will make a free body diagram. Next, apply natin yung ating Newton's first law. So first, the section with only one unknown variable. Okay. Okay, class. So isosolve na natin siya. So first, kunin muna natin, ano ko muna siya ha? Free body diagram muna. So for this example, wala siyang free body diagram. So kayong gagawa nito. Pero since, nasaan na yung ano? Okay, wala pala. So gagawa tayo ng kanyang free body diagram. So dito na lang. So ito. Sample lang niya ha. Okay, ang pangit. Okay, hirap magawa dito. So bear with me. So dapat straight. So gagawin muna natin yung axis niya. So x and y axis. Okay. Okay. So meron tayong force AB. Okay. Meron siyang 12 degrees na angle. And then sa kabila, force AC. Okay, so yung angle niya, kukunin pa natin with the given itong mga values na ito. So meron tayong mass na 12 kilogram. Okay. Okay, una kunin natin yung ating theta. So yung theta natin is gagamitin natin yung formula ng tan theta equals to y over x. So tan theta is equals to y over x. So ano yung value ng ating y? So yung y natin is itong 7. Okay, so 7 over x, ang x natin is yung 24. So yan na. So makukuha na ninyo ang ating theta for this angle. So yung theta natin is, may value ito na 16.26 degrees. Okay, so ito siya is 16.26 degrees. So next, may mass tayo na 12 kilogram. Pero ang ating ko consider dito sa ating free body diagram is yung kanyang weight. Okay, so ano ang kanyang weight? Ang weight natin, ang formula is mass times gravity. So 12 times 9.21. So 12 kilogram times 9.81 na value ng ating gravity. Okay, so may may weight tayo na 117.72 Newton. So yan na yung ating free body diagram. Okay, so ano natin siya sa kabila lang ha. Ilipat natin siya dito. Okay. So meron tayo dito AB 12 degrees. We have weight na 117.72 Newton. And then dito, meron tayong force AC na may angle na 16.26 Newton. Okay. So gagamitin natin dito na way of computation is yung way of computation is yung mag-summation tayo ng mga forces X component and forces ng ating Y component. So first is yung ating X component since ito silang dalawa. So summation of X equals to 0. So yung AC natin, negative direction. So negative AC cos, since yung ating mga angle is naka-direct sa ating x-axis. So cos 16.26 plus AB cos 12. So equals to 0. So again, equate natin siya like the same dun sa previous illustration. So AC cos 16.26 is equals to AB cos 12. Okay, hirap. Hirap siya ano ba? Pero sige lang. So, equate natin siya. Yung variable na lang natin is yung AB. So, yung AC mag-i-equal siya sa AB cos 12 over cos 16.26. Okay. Okay. So, next natin is yung ating summation of forces Y. So, dito na lang. So, f of Y, summation of f of Y is equals to 0. So, equate niyan is, since nakadirect yung ating mga angles sa x-axis, so yung mga y component natin nakasign. So, para positive and the negative direction. So, positive lahat yung ating forces AC and AB. So, AC, sine 16.26 plus AB, sine 12. Diretsuhin ko na ha, since magna-negative lang naman din itong weight natin, idiretso ko na siya sa kabila. So, sa or other side ng ating equal. So, equals, positive na ito siya. So, 17.72. Okay? So, ilipat natin or substitute natin itong value ng AC na to dito. So, para makuha natin yung value ng AB. So, magiging ganito siya. So, open parenthesis, AB cos 12 over cos 16.26 close parenthesis, and then itong value na ito. So, sine 16.26. And then, plus sine, nawala ang 12. Plus AB sine 12 is equals to 117.72. Okay, so ito, input nyo na ito sa inyong calculator. So, meron tayong pag-input sa calculator, itong AB na ito, represented siya as X. So, alpha X cos 12 over cos 16.26 times 16.26 plus AB, or yung ating alpha X, sine 12 equals to 117.72. And then, shift, so, equals, may value na kayo ng ating AB. So, yung ating AB, ang lumabas na value ay, okay, sandali lang. Okay, so may value tayo ng AB na 230. Okay. 238.69 Newton. 69 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 New And then yung ating AC, which is AC is equals to AB cos 12 over cos 16.26 may value tayo na substitute natin itong value ng AB dito. So meron tayong 243.20 Newton. Okay, so dito nagtatapos yung ating illustration para sa ating problem ideal cable. So para sa cable AB, meron tayong tension force na 238.69 Newton, and then cable AC, tension force na 243.20 Newton. Okay, next is yung ating, so ito yung kanyang summary of answers for the illustration sa ating ideal cable. Okay. So next is yung ating spring. Spring problems, pero before that, ano muna tayo? Yung kanyang force rules, define muna natin yung kanyang mga force rules. So para sa gravity near the surface of the earth, yung ating force is equals to mass times gravity, where yung G is the acceleration due to gravity na may value, constant number na 9.81 meter per second squared, kung meters, kilogram ang ating mga units. And then kung naka-pound, inches, or feet yung ating unit, ito ang ating gagamitin na value for the gravity na 32.2 feet per second squared. Okay, so next is the spring. Ito yung ating Hooke's law, which is dito magpo-focus yung ating equations or yung ating formula para sa ating spring. So spring or yung Hooke's law in one dimension. So yung force natin is equals to negative K delta X or Kx. So yung K natin, yan yung siya yung stiffness. Stiffness constant number yan siya ha. Stiffness number. And then yung delta X is yan yung ating displacement of mass on the spring from the equilibrium. Kumbaga yung spring natin na wala pa siyang mass, and then yung kanyang displacement or yung kanyang distance nung stretch niya nung meron na siyang mass. And then next is yung normal force natin is dito sa free body diagram is yung perpendicular to the surface. Yan siya yung ating normal force supporting the mass. So nakadepende itong normal force natin sa surface natin kung saan siya nakalagay. Kung naka-horizontal lang ito siya or naka-inclined. Next is yung tension natin. So same lang siya sa normal force. So yung statics natin para sa yung ating spring. So before we proceed sa ating mga problems or illustration, meron tayong mga certain conditions dito. Excuse me. So yung linear elastic spring, change in length is directly proportional to the force acting on it. Yung spring constant or stiffness K defines the elasticity of the spring. So yan siya, yung K natin. So yung formula natin ha, Ks. And then yung magnitude of force when the spring is elongated or compressed, yung ating F. So here we have a sample or illustration. Spring AB is stretched 3 meters. What is the mass of the suspended block? So ano ang mass nito? So sa problem na given sa atin, no, ang binigay lang is yung ating AB na stretch na siya ng 3 meters. And then meron tayong mga stiffness number dito sa ating AB na KAB na 30 Newton per meter. Sa ano naman, sa KAC 20 Newton per meter, and then sa KAD is 40 Newton per meter. Okay, next ang gagawin natin is gagawa tayo ng kanyang free body diagram para sa spring forces na ito, force system. So, gagawa tayo ng free body diagram niya. So, somehow ito na siya pero igawa lang tayo. Okay, so meron tayong AB. Okay. So AB. And then yung kanyang run and then rise, kumbaga, X and Y niya. Balik lang tayo ha. So yung X niya 4, yung Y niya is 3. So ano na natin siya dito, illustrate lang natin. So yung Y niya, by direction niya 3 meters and then 4 meters. And then dito sa kabila, 3 meters yun siya. So 3 meters, 3 meters. So pwede lang natin siyang gawin na 1, 1, 1, 1. And then force AC. And then dito yung ating force AD. Okay. So first kunin natin ang theta na to. Ano to siya? So gagawa tayo dito ng tan theta sub 1 is equals to 1 over 1. So anong lalabas na value na ating theta? Ang value is 45 degrees. Okay? The next, dito. Kumbaga dito 45 degrees, di ba? So next, ano naman ang ating angle dito? So tan theta sub 2 is equals to y over x. So ang y natin 3 over 4. So ang tan theta 2 is equals to 36.87 degrees. So yan siya yung ating angle for this inclination. 6.87 degrees. Okay. So next, kukunin natin yung force AB natin, which is, bakit siya yung ating kukunin? Kasi doon sa problem, siya lang yung merong values or yung may mga data. So yung formula nga natin, di ba? For the spring is K equals to KS. Yung K natin is yung ating stiffness, which is given na. Ito 30 Newton per meter. Okay? So equals to, ulitin ko lang dito ha. So 30. And then, nabigay na din ang kanyang stretch length na 3 meters. So ilagay na natin siya. So 3. So ito siya, Newton per meter. Ito meter. So makakancel out lang yung meter. Mangyayari, ang value ng ating force AB is 90 Newton. Okay? So, yan na. 90 Newton. Okay. So, gagawa naman tayo again ng force free body diagram. Dito natin gagawin na. So meron tayo dito. Force AB na 90 Newton. Na may angle na 36.87 degrees. Tapos dito is yung ating force AC, which is may angle na 45 degrees. And then yung force AD natin dito. So, gagawin natin dito yung mag-summation naman tayo ulit ng mga forces. So, first is yung summation of, summation of forces F sub X is equals to 0. Okay, so AC cos 45 is equals to, mabilisan na to ha kasi paulit-ulit naman ito siya. So AC cos 45 is equals to 90 cos, so 90 cos 36.85. 87 pala. So, meron lang tayong isang unknown. Makukuha na natin agad yung ating value para sa AC. So, ano lang natin na, shift solve na tayo para hindi na matagalan. So ano yung value ng ating AC? So, may value tayo ng AC na 101.82 Newton. Okay. So, next, kukunin na natin yung value para sa AD. Pero, makukuha natin yan siya with the equation sa summation of F sub Y equals to 0. Okay? So, dara-diretso na tayo nito ha. So, AC sin 45 plus 90 sin 36.87. Is equals to AD, di ba? Okay. So may value na tayo sa AC. I-substitute na lang natin dyan para makukuha na natin yung value ng ating AD. So AD is equals to 101.82 sin 45 plus 90 sin 36.87. So, input sa calculator, may value tayo ng AD na 126 Newton. Okay? So, yan na yung mga values natin. So, may value na yan ating AC and AD. Next, kunin natin yung mass ng ating block, suspended block. So, from force AD, diba? Force AD ito ha, which is 126 Newton. Kukuha natin yung mass sa formula na F AD equals to mass times gravity. Okay? So, yung FAD natin is 126 equals to mass. And then yung gravity natin na 9.81 meter per second squared. Okay. So, i-divide lang natin ito dito, di ba? Okay, diretso na tayo. So, ang mass natin, input sa calculator, may mass tayong lalabas na 12.84 kilogram. Okay. So, ito yung answer sa ating problem. So, what is the mass of the suspended block doon sa force AD? So, meron tayong mass na 12.84 kilogram. Okay? So, next is beam illustration na tayo. So, here, meron tayong figure na beam. Supported siya sa ating A and B. Support A and B. So may weight tayo dito na 14 Newton and then may weight dito na 18 Newton. So ito yung kanyang simplified form or free body diagram niya. So may 2 meters, 7 meters, 3 meters. So from support A to support B, meron siyang direction or range distance na 10 meters. Okay, find the forces exerted by support A and B. Neglect the weight of the 10-meter beam, or yung 10-meter beam na ito is from A to B. So, pero total length ng ating beam is 12 ha. So, huwag kayo malito dyan. Sa support A and B lang na itong 10 meters na ito. So, procedure, rotational equilibrium ang ating procedure for this illustration. Choose an axis at point of unknown force. Kumbaga, dito, gagamitin natin dito. First is dito tayo mag-equate sa ating support A. So, yung rotational equilibrium natin, kumbaga, yung ating counterclockwise is equals to the clockwise rotation. Essentially, we are saying that the torques are balanced about a chosen axis. Okay? So, okay, here, gagawa tayo ng free body diagram niya. So, ito na. Ito yung ating free body diagram. Pero ano lang tayo, gawin na natin mas depth na free body diagram. So, ito yung ating beam. At then, ito yung ating support sa A. And then, support sa B. So, dun sa ating support A, meron tayong reaction dyan. So, a vertical reaction upward. So, R sub A, reaction A. And then, dun sa support B, meron din. So, meron tayong R sub B, reaction B. And then, i-illustrate lang natin dito, meron tayo dito 40 Newton na weight. Okay. And then, yung distance from that weight to the support natin sa A ay yung, so, point A is 2 meters. Okay, di ba? Next is, meron tayo dito 80 Newton naman. Di ba? Tapos, distance niya from support A is 7 meters. And then, ito naman is 3 meters. Okay, 3 meters. So, ang gagawin natin, like kanina yung sinabi, choose an axis at a point of unknown force. So, gagamitin natin yung, dun tayo mag-summation ng moment of forces. Moment of forces ang gagawin natin dito since meron na tayong mga distances. So, moment of forces at A equals to 0. So, ganito siya. So, moment of forces, M, A, is equals to 0. Okay. So, ang gagamitin natin na positive, kumbaga gagawa tayo ng ating representation ng positive. So, counterclockwise yung ating gagawin na positive. So, ito siya. So, positive, CCW. So itong ating 40 Newton, kung ito yung ating point of reference, yung ating A, ano ang kanyang rotation? So from here, may 2 meters and then 40 Newton na pababa. So ang kanyang rotation is counterclockwise. So meron tayong positive. So 40 times 2. So positive na siya. So hindi ko na siya i-elaborate pa na positive dito. So next is yung ating 80 Newton na weight. So ang kanyang distance is 7 meters and then ang kanyang weight na downward direction 80 Newton. So ang kanyang rotation is clockwise. So since hindi siya counterclockwise, negative ang ating representation. So negative 80 times yung kanyang direction na 7 meters. Okay. So last is itong reaction force na ito. So meron tayong distance na 10 meters, di ba? 7 plus 3, so 10 meters from the support A to support B. So 10 meters, ang ating reaction is upward force. So meron tayong rotation na counterclockwise. So positive tayo. So 10 and then yung reaction B, RB, is equals to 0. Okay? So ito na yung ating moment of forces. So i-ano lang natin, i-compute lang. So 80 ito. So minus 560 ito. plus 10 R sub B equals to 0. Okay. So ito, 560, negative 560, positive 80. So meron tayong negative 480, di ba? So plus 10 R sub B equals to 0. Okay, so ilipat lang natin ito para mag-positive. So 10 R sub B is equals to 480. So kunin na natin yung ating reaction B. So meron tayong value ng R sub B na 480 divide 10. So merong 48 Newton. So yan na. Meron tayong value na 48 Newton para sa reaction at B. So next, kukunin natin yung ating reaction at A. So illustrate naman natin dito. Okay, again. So meron tayo dito 40. And then reaction B. A. And then yung 80 natin dito. And then reaction at B. Okay. So for this, may value na tayo para sa B. So yung R sub A lang yung wala. So ang gagawin na natin dyan is magsasummation na tayo ng forces vertical. Vertical equals to 0. Okay? So ang partnering nito, magpa-partner-partner. So yung upward is equals to downward forces. Okay. Downward forces. So R sub A, partner niya si R sub B. So R sub A plus R sub B is equals to 40 plus 80. Diba? So yan na-equate na natin itong forces na to sa equation of F sub Y. Summation of F sub Y. So yung R sub A is unknown. Pero yung R sub B natin is nakuha na natin. So which is 48 Newton. Is equals to 40 plus 80. Meron tayong 120. 120. So ilipat na natin itong 48 dito sa kabila para makuha na natin yung ating reaction at A. So reaction at A is equals to 120 minus 48. So input lang sa calculator. May value na tayo sa ating R sub A, which is 72 Newton. Okay. So nasagot na natin yung ating beam illustration. So dito nagtatapos yung ating mga mga sample illustration or problems. So next ito yung kanyang summary of answers. So again, yung B natin 48 Newton and then yung A natin is 72 Newton. So last, meron kayong assignment. Okay? Or sheet work ito yung bibigay. So paki-screenshot ito. So ito yung inyong assignment na dapat ma-solve. Okay, find the forces in all 5 cables. Okay, so dito nagtatapos yung ating video presentation. So magsasend lang ako for the next discussion, yung kinematics natin. Kinematics. Okay class, thank you.